are at IMS 2023 in San Diego, where we're talking about RF microwave and millimeter wave technology. And today I am joined by my friend and teacher, John Coonrod from Rogers Corporations. John, always good to see you.
Always good to be here.
And see what you got up your sleeve for this year.
Sure.
So I know you're doing a couple micro app talks.
Right.
So why don't you jump in and tell me what you're going to be presenting?
Be happy to. Yeah, the micro apps, I'm actually doing two of them. And the micro apps are nice because they're open to everybody, so you can just come and sit down and watch. And the first one is on thermal consistency of millimeter wave circuits. And I've done that really because we run into so many different issues with millimeter wave that the RF designers a lot of times are not that familiar with, because a lot of these applications of millimeter wave are newer applications, and with that you've got a learning curve that goes along with it. And we've run into a lot of different thermal issues where as the circuit goes through normal thermal cycles, it warms up, cools down, that actually can change the performance of the circuit. And that can happen at lower frequency, but actually at higher frequency it seems to be more dramatic. And it could just be that the designs are more sensitive. So for millimeter wave designs, the wave itself, or the wavelength, is physically very small, and because of that, it's more sensitive to things that larger waves, lower frequency, are not sensitive to.
I see.
So anyway, the thermal thing, one of them is dielectric constant changing with temperature, and that's true with all materials. It's called TCDK. And at millimeter wave frequencies, that can be a real problem because some of the millimeter wave applications need to have very consistent phase response. And phase response is related to constant dielectric constant, or more consistent dielectric constant. And so that's one of the topics. There's several others, though. There's just a lot of different things that goes on at millimeter wave that the designer needs to be more aware of, that is not as important at lower frequency.
Right.
And then the other micro-apps is on Radix. It's a 3D printable material, and that material has good RF properties. It's one of our newer materials we brought to the market, and we've been working with a company called Fortify out of Boston, and they make 3D printed machines, so they have an expertise in 3D printing, and then we've developed the formulation for it.
I see.
So between the two of us, the two companies, we've done really well in bringing to the market the first that I know of, low-loss 3D printable material. So there's a lot of 3D printable materials out there, but none that really has good RF properties like low dissipation factor, consistent dielectric constant, moisture absorption, blah, blah, blah. All those things. But Radix does that, and Radix is our 3D printable product. And there's several different things you can do with Radix. To me, it's just fun because you can think of a concept, do some simulations. Within a few hours, you can get it printed, try it and see how it works. And if it doesn't work, you go back to simulation, make a little tweak, do it again. So it's a really good way to check out some concepts. But besides that, it's also possible to make things that are scalable to high volume manufacturing. So that's the good thing about working with Fortify.
Right.
They're able to do that, and our resin system is friendly to faster processing too. So it's all around a really interesting product.
Yeah, and there have been some other RF printable things out there, but not scalable.
That's true. Yeah,
right?
yeah, right.
I mean, I'm thinking of companies like Nano Dimensions or
Right,
things
right.
like that, which is great for certain applications,
Sure.
but it's not going to scale.
Right.
So what has been sort of feedback you've been getting around Radix, and are there specific applications?
Yeah, I think what we decided to do, just because it's almost like you're opening up a new toolkit. There's all kinds of fun things you can do with Radix.
Right.
And since a lot of people haven't had this before, they're not too sure what to think of it.
Right.
So I think what we decided to do is start off with something relatively simple that can prove the point of some of the things you can do by thinking out of the box. And one of them is what I'm holding, and this is a Lundberg lens, and it's designed to operate about 39 gigahertz, I believe. And it's really interesting because it's using GRIN technology. GRIN's the acronym for gradient index. And essentially what it's saying is that the dielectric constant will spatially vary throughout the cross-section of the material. And in this case, the dielectric constant, or the 3D printed object, is so sparse on the outside for density that you have a very low dielectric constant. As you move in, it gets more dense until you're in the middle, and it's a solid core. So you really have a dielectric constant on the outside that might be 1.1 and then 1.2, 1.3, working all the way into the bulk decay of the material, which is about 2.6, 2.8, someplace around there. And anyway, in this case, what the Lumberg lens does is you can put it on like a simple microstrip patch radiating element, and it will form the radiation pattern in the way that this is designed to. In some ways, you could actually have it form in almost a pencil beam, so you have a really very strong directivity. And it can be designed a lot of different ways, though. But I just think it's such neat technology. If nothing else, it's cool to look at, too.
Well, so in other words, you've developed it, has great products, and it sounds like engineers are going to end up playing it with particular applications that it works for, and they're going to end up telling you, getting back to you about, I did this, and then it's going to be sort of developed from engineers.
Yep, I think so. Yeah, and one of the things I was working on a couple of weeks ago was a radome that I want to put right directly on a circuit. So I have a 4350B based circuit. It's just simple microstrip patch radiating, and then I put a radome over it. And the radome essentially is there to protect the elements, but you can actually get a lens effect out of it, and you can create a radome where it protects it, of course, but also it can alter the radiation patterns. And sometimes in radiation patterns they have side lobes that they don't want. They're unwanted modes, and you don't want those. So you can actually design this radome to be able to have areas where it's going to subdue those or suppress them, and then you don't have the problem with these side lobes. And that's just all part of the design. And the nice thing about it is if you don't like it, you can go back and try something again, reprint it, and see how it works.
Right.
And there's just a lot of things that you can do with it, though.
So will that material run on standard 3D printers?
It's really developed and designed to run on a DLP printer, which is digital light processing, if I remember right. But it's basically a laser printer. And then there's also SLP printer, and those are the two 3D technologies that it's really designed to work on. And both of them, as I understand, are scalable to higher manufacturing. I know the DLP is, not 100% sure about the SLP.
Okay. All right. Well, we've talked many times, and again, you've been my teacher for many years, and taught me words like spurious modes.
Oh, yeah. That's a good one.
But I know that you have a lot available in the Tech Hub, so for our listeners, why don't you give tell them a little bit about the Tech Hub, and then I'll make sure that I share it in the show notes so they can go dig in. If they're not here at the show, there's lots of resources. So.
Oh, yeah. Yeah, the Tech Hub, we're really proud of that. We've been working on that for a number of years. And we have articles in there that we've written for different magazines in the industry. We have papers that we've actually videoed at some of the trade shows like this. And we also have the paper itself there, of course, and presentations. And we have a pretty good video library, actually.
Yeah.
And also have my Coonrod's Corner videos on there, which are really meant to be just a topic on, some topic that's just a short video, maybe 5-10 minutes long, just to kind of get the ideas out there. And we also have the ability to contact the engineer in your area, and we have, I don't know how many different articles in there now, but it's we got an article on just about any topic you can run into for RF.
Yeah. And you have some tools in there too, right? Like calculators and...
Yep. Yeah, we have our MWI calculator. MWI 2019 is what's on the Tech Support Hub right now. And that's an impedance calculator, but it actually does a little more than that. It will also do basic loss calculations, microstrip and strip line and grounded coplanar. And also it will give you design decay, which is the dielectric constant that should be used in the design and simulation phases. And we also have other calculators on there as well. One's a ring resonator. Don't know how much that's used, but I use it a lot. But anyway, the ring resonator is actually really helpful for me and anyone that's actually wanting to make a test structure, because that's usually how ring resonators are used. A lot of times on a panel of circuits, they'll have a ring resonator off to the side, and each panel might have a coupon in there. You can pop it out and test it real quick. But we have several different software on there. It's all free for download, free for use.
Yeah. So again, for our audience, I highly recommend it. There's also an app, I think, where you can tap in, and your colleague Cheryl told me that you're updating that to be more mobile friendly soon.
Right.
So make sure you go check that out. And then for people who want to learn more about Radix, where can they go find the data sheet and find out more information?
Right. Yeah, on our website, that's where the data sheet is at. Also on our website, besides the data sheet, we also have a product selector guide, and that's a really good tool, I think, because you can get on the product selector guide and you see all of our materials all in the same document, and you can kind of mix and match and look at DK here, and you can kind of figure out what you really want for the application that you're working on. But Radix is all part of that, and it's on our website, so it's easily found there anyway.
Okay. Well, very good. Well, thank you again for joining, and good luck with your micro app presentations. And it's always good to see you. And
my pleasure.
You guys always seem to be hopping busy at this.
Oh yeah. Yep, it's a good show.
It's a great show.
Yep.
And so thanks again, and I will make sure to put those links for our audience in the show notes. Thanks so much for stopping by. For our listeners, thanks for tuning in, and make sure you go check out the show notes so you can tap in those resources. We'll see you next time. Until then, remember to always stay connected to the ecosystem.